This is the fourth in a series of videos in which I am restoring a Creed 7B Mark I teleprinter, and today I'm looking at the print selector head. This is quite a clever piece of the machine. The way the machine prints is that it has a disc with all the characters embossed on metal plates, and to print it selects the correct plate that it wants to print with, very like a daisy wheel printer, and then it impacts that plate against the paper through a ribbon. So very similar to a daisy wheel printer. This unit is responsible for selecting the correct character to print, and it's quite clever the way it works. It's similar in operation to the way the keyboard works, except that it's in a cylindrical form. So essentially what the unit consists of is a series of coded discs, each one with a lever attached to it, and the discs have cutouts that are arranged in such a way as to allow different combinations of these lever positions to allow only one of these levers to drop down into the slots that are in the discs. Every single lever is spring loaded, so they're always trying to drop down into the slots, but they can't do that unless there is a row of slots adjacent to each particular lever. That is, the coded discs all have to have a slot lined up underneath a particular lever before that lever can drop down into that combination of slots. When they do that, the particular lever drops into the space that the clutch cam rotates in, and that will cause the cam, which is this, to stop in a particular position. This in turn drives the daisy wheel print disc, so depending on which of these levers is encroaching into this space, that will determine where this stops and hence which character is printed. And they're all, in theory at least, mutually exclusive, so only one can drop into the space at any one time. And this shaft is driven from the main motor drives. In other words, this is rotating all the time, and then depending on the combination that's applied to these levers, which is in turn dependent on the character typed on the keyboard or the character received through or from the remote terminal. So the solenoid is responsible for taking the incoming pulses, and then effectively it pulses the drive that sets the position of these 5 levers. It's a 5-bit machine, and then depending on what the combination of these levers is, up is a 1, down is a 0, or mark space depending on how you want to term it, then this combination decides which lever drops into the space and hence which character is printed. And then at the end of the cycle, this unit sweeps round, pushes all the levers back out again, and then it's ready for the next character to print. So it all happens at quite a high speed. It's complicated by the fact this drives continuously, so there's a clutch in here, which is what this arrangement is, so that once it's hit the stop, the motor can carry on turning even though it's currently printing a particular character. So I'll try and demonstrate the operation. It's quite difficult to get a particular character to come out because it's quite a stiff spring system. But if I push, this is the stop, this is always the one that comes out at the end of a particular character, so this is, if you like, the stop bit. So once this is pushed in by the rotating cam plate, then the levers can be moved depending on what the solenoid instructs them to do. So in theory at least, I should be able to move one of these levers, which I've done there, and you can see that this particular plate, I don't know how clear it is on camera, this plate's moved into the space, and that will now cause the cam plate to stop in a particular position, and that will select a particular character. At the end of the print, the cam plate comes around and pushes all these back out again to zero the combination on the levers, and it's ready to go through the same cycle again and select the next character. So again, I've selected the character, the plates pop back out, the stop bit is now held out because, as I said, these are mutually exclusive, so only one character can come in at any one time. And then when the cam plate comes around again to reset, you'll see that the selection levers all move to their default positions, and then the stop bit character plate will pop back out, which is what's happened there. And then it just repeats that depending on what the incoming data instructs it to do. So what I've done is take this apart and clean it. I'm in the process of reassembling it. It was actually seized up, I couldn't get it to turn, and these are all stuck, so I've freed them all up. I just now need to reassemble it, put it back into the casting that it sits in. What I'm doing with the teletype is some of it I will be repainting. The base I've decided to repaint, it's in fairly poor state. The paint looks quite good, but it is peeling off, but parts like this aren't too bad, so I'm going to leave this and try and keep some of the original character. So I've lubricated all the levers, I've lubricated the encoder discs, and what I'm going to do now is reassemble the clutch and the clutch selector plate. So the first thing I want to do is lubricate the various parts. So you can see these parts are in remarkably good condition. These are specialist lubricant for these. It's a combination of grease and oil. It's kind of thinner than grease, but it stays in place better than oil does, and it's extremely good for this sort of application. For the rest of the unit, I used a good quality machine, very light machine oil. Okay, so that then sits in there. So remove any excess. Okay. And I'll do the same with the bearing shaft, but first I need to refit the clutch spring. So that sits inside this recess. The friction surface isn't looking too bad, although it is a little bit warm, as you'd expect. So I need to get this into the recess without it disappearing across the room. Okay, and then this sits in here with the two prongs on the inside fitting inside the two recesses. Before I put that in place, I need to get some lubricant onto the shaft. Now, I don't want too much in there because I don't want it getting onto the friction material of the clutch. So take off the excess, and then try and get these two parts to align with the holes in the clutch spring. Okay, that's on. Now I need to fit the retaining boss on the end. Okay, then we'll test if the clutch works. It should spin in one direction but not the other, so if I try and turn it this way, as you can see, I can turn the gear. There's quite a good amount of tension, but it's not horrendously tight. If I turn it the other way, it just locks up, so that's the way it's intended to work. You don't want a horrendous amount of force on it, but then it needs to be enough to actually drive the mechanism round. We can see that in the stop position we have the stop bit plate out, so it will go so far and then stop. Whereas going the other way, it will sweep all the plates into their home position. So again, that seems to be working as it should. Next thing is to mount this back inside its casting, and it only goes on one way round. and there is a locating dowel at the bearing end, so make sure that goes in squarely and we don't bend it. Then we have this, which is a centering adjustment. So what I have to do is lift up the assembly until the pin on that sits inside. There's a little recess in here and it has to sit in there. So I'll probably get my hand in the way, but okay. I just need to do that tight enough so it can't move. Snug that up so it can't come loose. And then we put in place the clamping ring. It's important to do it this way around. If we do it the other way around, then we won't be able to line the notch in the centering pin. And this is just a strap to stop the whole thing from popping out. So I spent quite a bit of time cleaning these. They were not too bad, but they certainly needed a clean and a bit of de-rusting. And again, they don't need to be too tight. Okay, so that's that part, and then the last piece to fit back on is the guy plate. Again, this is a very nice design. Most of the parts will only go on one way around. So what they've done with this is they've got the mounting hole and the pins offset, so it just will not fit on upside down, which is quite a nice touch. So we'll get all the levers to go through their respective holes. Get this mounted onto the locating pins, and then we can put the fixing screw back in. Okay, and we're back assembled. So this bit, as I say, engages with the mechanism that selects the particular character on the daisy wheel. So I'll look at that in the next video, and then we'll just temporarily hook the two together and try and demonstrate exactly how these work. This lever incidentally effectively selects different character sets. So there are two different characters that can be selected depending on the 5 combinations of lever positions, and this just allows the alternate characters. Again, quite a nice design. It seems way over engineered, but part of this is because it does run at a relatively high speed for a mechanical design, and it is a very interesting machine to work on. So that's it for this video. As I say, in the next video we'll look at the actual print head and the daisy wheel and see how that fits onto this mechanism.